We can I'll just yes. Am I audible, sir?
Yes, sir, very much.
Uh, Good morning, everyone. So today I welcome to the session number three of Atal sponsored faculty development program on IoT-based applied engineering in agriculture. Today we have with us Dr. Anukram Mishra, sir, who is the Chief Technical Officer at Genus Power Infrastructures Limited. Welcome, sir. I'll just give a brief introduction about Sir. Sir has done his Bachelor's of Engineering honors from Electronics and Communication Engineering, MBM Engineering College, Jodhpur in the year of 1986. He has done the aircraft production engineering from IIT Madras in the year of 1990. He has done the MTech degree from there, and he has obtained the PhD in Constrained Bandwidth Advanced Meeting Infrastructure from Department of Computer Science of MNIT, Jaipur. He has over 33 years of field expertise, in which 7 years as inertial navigation and attack system Jaguar at Hindustan Aeronautics Limited, and in 26 years as automatic testing of hybrid microcircuits, metering solutions, smart meters, communication technologies for advanced metering infrastructure, smart grid at Genus, Jaipur, and Landsys plus Jair Global Development Center, Noida. We welcome you here, sir.
Yeah. Thanks a lot, Professor Parikshit. It was a pleasure to be part of this program. I welcome all the delegates. They say uh, I take great pride in teaching the teachers. So, since the audience are teachers, I would expect that there will be lot many questions in the end, and we'll end up on a note of satisfaction. Uh, Two-way communication between me and the rest of the participants. Uh, it's really great to know the topic. Very interesting and a very different topic which has been selected for this FDP. We have been, since the school days, we have been reading in the textbooks that India is a country driven by agriculture. And we have seen the revolution taking place, the Harit Kranti. But now this is the time in the coming years to witness a different type of Kranti in the field of agriculture using the new technologies which are available today. So in today's session, we would try to do justice to so many keywords in this slide itself. One is the agriculture, the other is the standards. And standards, I can share with you, can be a very boring subject also. So it will be our endeavor to make it more interesting. And you can interrupt me anytime if you have a question, or I would suggest that we finish this presentation in 1 hour and then keep half an hour for a very interesting debate on many interesting and exciting topics that we would be able to pick up from this presentation. Going forward, uh, the flow of the presentation uh, would be we'll be covering the big picture of IoT, Internet of Things. the general theory on how to have a vision, what is technology, and finally what is agriculture 4.0. We would have read a lot about industry 4.0, but let us see if the same principles of cyber physics, cyber physical systems can be applied to agriculture as well. We will spend considerable time on understanding the importance of standards when we design systems. And then there are a lot many technologies which are also evolving along with IoT. So we'll have a discussion on the different types of technologies, the RF, the cellular, and the power line carrier communication, uh, which is relevant to this subject. And then we'll take one example of the application layer standard and browse through the other standards, because when we talk of standards, it's an ocean. We will also see how to, don't inundate ourselves in that plethora of standards and confuse ourselves. In the end, we will also see with the new technologies, new challenges are there. What we can do to mitigate those. What we can do to have the security aspect also taken care of. And in the end, we will conclude. So starting from the first uh, point, uh, technology. This one quote I like about technology: that technology is like oxygen. It is ubiquitous. It is everywhere. It is necessary for us, and we will call it a technology if it is invisible. What do we mean by that? For example, you go to your office, you lock your door, you sit in a car, you don't have to drive the car knows where you have to go. And then when you come back, you don't have to search for a key to open the door of your house. The house recognizes you, and the door automatically opens, and you are given the access control. All the lights light up as you enter, and all the air conditioners, to your surprise, are already on, based on the data, the intelligence, and the action which the technology has taken. So this is the vision of technology that we should carry, and why we will come to that later. Coming to the evolution in agriculture, we have always seen that there were new machines coming in, and the effort of the farmer got reduced in the process. Same way it happened in other fields also. If you see a very simple example, a wristwatch. Uh, the purpose of a wristwatch was to keep time and keep that precisely. So there used to be Swiss watches, German watches, engineered with precision and with jeweled bearings so that there is no wear and tear and its impact on the timekeeping. And then came the era when all these watches were replaced by electronic and quartz based measurement, batteries inside those watches. And but the face was still mechanical dial. Uh, so that was the time how this thing evolved. Then came the time when you see people wearing smart watches. Now, smart watches are not only having a fully electronic setup, fully electronic functioning, but also they have user interface which is totally electronic, and on top of it, they are now able to communicate to the cloud, and all the data it is sending, it is processed, and not only for you, for all those millions of people who are wearing smartwatches. So that data is converted into useful information or actions, and it is fed back to you through your mobile. If you see, the similar type of things are happening in other fields also. My field where I come from is smart grid and smart meters. The meters were also like these watches. In late 90s, those were converted to static meters. The measurement became electronic. As a result, the effect of wear and tear was reduced and the sustained accuracy was obtained. And then some anti-tamper features were also introduced. But now is the time when the meters are all having the capability of two-way communication. A lot of data is generated and it is communicated back to the server where it is processed in real time because the technology is available now. Now, what that is achieving, that with that data, a lot many things can be done. Apart from just billing you or making the consumer aware on his mobile about his projected bill, these are some of the things. But more important than that, a good, precise uh, prediction or forecasting of the demand in the coming years can be made based on this data, based on the weather model, based on many other models which are available, and this would help the utilities to book electricity in future at a lower price, and consumers will face less power cuts because there won't be any surprises like a peak demand coming in without any knowledge of it. So that is all on this slide. We move to the next one, and here I would like to say that Internet of Things devices are part of a larger system. Alone, any device like we saw in the previous slide, a smartwatch, cannot exist on its own. It has to be supported by an environment. And what is that environment? This sensor is doing some measurement, it is collecting some information. Then there is a gateway through which it is sending that information to the cloud, and then that information is collected in the database, and a real-time analytics is working on it to come out with something useful, which is again fed back to the user in terms of some information or an action. So when we talk of IoT, when we talk of IoT standards, we need to see that we talk of the entire end-to-end system and not just the device. Agriculture. So why agriculture is now again becoming important, not only for India, but for the world. So I was researching through and saw this input from UN that right now the population of the world is 7.8 billion, and this is going to rise uh, uh, exponentially in the coming years, and this is going to reach 9.7 billion. What is the implication for us? That would mean that so many people will be needing more food, and all that we could do, that we have machines in the farms, we have all the biotechnologies and thing, but it seems that all that will not be sufficient unless we do something different to meet the food requirements in 2050. And this is where the topic becomes very relevant today. How do we incorporate the new technologies in the field of agriculture? And it becomes very exciting also. When we talked of sensors, so there can be sensors in the farm for measuring humidity, for measuring temperature, the pH or the acidity of the soil. There can be actuators like drones, which are controlled by the cyber systems, and the entire system can run on its own, collecting data and based on artificial intelligence, making itself more knowledgeable and becoming better and better. So this is the future that we see in this area, and the need is the need of survival, the food for so many people, according to the prediction in the coming years. Uh, John Deere is a company worth mentioning here, which is working on the technologies which are required in agriculture, starting from self-driven tractors and use of sensors, the communication technologies, and the analysis of it, and then providing the apps to the farmers. Uh, in the times of COVID, this is again a very interesting question we can ask ourselves. Can farmers work from home? The drones, they are controlled by, again, the cyber systems, and they can do a lot of work, irrigation, uh, spray of pesticides and other things. Agriculture 4.0, Industry 4.0 is happening right now. In all the factories, the cyber world is working parallel to the physical system. The machines are working, data is collected parallelly, the data is analyzed through the data science models, and as a result, there are certain actions, certain process changes which are taking place in real time, which are improving the output, which are improving the productivity or the quality. Same way, we can see that agriculture 4.0 is also knocking our doors. We see drone technologies, data analytics, Internet of Things entering agriculture today. And in future, we would see the other technologies of artificial intelligence, nanotechnology, and blockchain uh, helping the humanity to prepare for the coming years. Uh, as a as a proof of it, you can also see that the IoT devices shipments globally have been increasing exponentially in just the last 5 years. From about 30 million, they have reached 75 million. So, what is happening in our space since 2007, as the experts say? That device capabilities have been enhancing like anything after the ARM-based architecture became very popular. So from 8-bit controllers, things have, even for the smallest controller, they have moved to 32-bit. The power consumption which these devices are having, this has also reduced drastically. It is measured in terms of milliampere per MIP. So that is into some nanoamperes now. Parallelly, there has been a revolution taking place which gave rise to IoT from IPv4, where the internet addresses available to us were only 4 bytes. So it was a limited space available in the internet, and that was enhanced to 128 bits. And as a result, now billions and trillions of IoT devices are envisaged. So this is another contributor. Communication technology, we see that a lot many LPWAN technologies are there working in the RF spectrum. And then in the licensed band, we have cellular technologies where we are reaching 5G. Computation power has also been increasing since uh, Moore's law predicted that every 2 years there'll be the number of transistors will be doubling in a per square centimeter of wafer space, and it was reiterated by Intel CEO in 2017 that it is very much alive and very well flourishing. You can see the result in the new mobiles, quad core uh, processors, octa-core processor, 8 processors working in a single chip. You can very well imagine the power they might be generating in terms of horsepower of processing and parallel processing so many things, so much of data in real time, and moving towards quantum computing, which is again a computing principle on a different plane. Uh, and then we hear a lot about data science, the big data generated by the billions of IoT sensors and the ability to collect data in real time and process it, and then process it using the new principle of artificial intelligence, machine learning, and so on and so forth. So, so all that what is happening, it is not contributed by just one discipline. It is a multiple. in a combination of discipline where revolutions took place in the last 13 years, and what we see today and what we'll be seeing in next 50 years is a result of all this. IoT devices have been again growing exponentially, and this is the scale is billions, and you can see that today in 2020 we are at about 21.2 billion, and in the coming 5 years this number will be 34.2 billion when it comes to processors and electronic devices. And the uh, red one is the IoT devices. From 10 billion, they will be like 21.5 billion. So this is the type of projection we have in terms of IoT. And within the IoT, what are the technologies those devices are on? Major space today is taken by the Bluetooth technology, which is now the de facto technology for communication in all the gadgets. Zigbee, which we feel is now dying its own death slowly. The Wi-Fi in the offices, in the homes for routers and for internet connectivity. And then when we go out of the building, we have RF mesh in the RF spectrum, LoRa technology, and then there are so many LPWAN technologies like weightless, my IoT, and so many others. So a lot of work is going on in this area. And then the small spaces which are held by cellular, and this is also going to increase in the future. IoT sensor is the heart of the system. Now, whole issue started with the IoT sensor generating so much of data. If the sensor wouldn't have been there, we won't be bothering about the big data analytics and the machine learning. So this is the heart where all the data is coming from. It is coming from these billions, and now in 2035, it is projected that this is going to reach trillion number. So this is all coming from the IoT sensor. And a quote by Lord Kelvin that if you cannot measure it, you can't improve it is relevant today. But in addition to that, if you also add that if you have a lot of knowledge and you communicate information, process and act in real time, uh, this is what is happening today. And this is you can, in a nutshell, you can say that IoT sensor is a very important element of the entire system, where it is now possible that so many scaled up sensors in the world will be able to communicate effectively with the IoT technologies. So we would conclude this part of the presentation by saying that it is all about the data. And people say that data is the new oil. Earlier world wars were fought on uh, the core issue of uh, oil, and we would have seen that early 90s in the days of Iraq and US fighting it over the oil and all that. But the wars today, the Cold Wars or the aggressive wars which are being uh, fought today are basically on the data. Data has become very important, and everybody is now understanding the value of the data and fighting hard to capture it and do something about it. It could be on the negative, it can have negative connotation also, like we saw some companies stealing data from Canada and US. And it could be on the positive side also, that the data is being used to enhance the life of mankind. The technology is reaching the last person in the chain. So the data can help in a positive aspect also. And this is what is our intention. Key points, we can summarize that sensors are at the heart, and IoT enables that communication in real time. When you have so much of data, you need to have the technology to collect the data and to process it in the real time. So all those data science related things are enabling that. And using that, precise predictions can also be made so that nothing comes as a surprise. And mankind, the humans, are very well prepared for what is coming in the future. Agriculture 4.0, a combination of physical systems like they have been there, uh, augmented by many technologies, biotechnologies, this, that. But again, very well supported by the IoT sensors, the data, and some real-time actions taken place, preserving the resources, sustainability, all that, you can think that uh, it is helped by agriculture 4.2. So in the end, we can say that humans are having, unlike other animals, having a lot of brains. So they should be having the time to do exploratory things for continuous improvement. And something which is mundane or something which is routine should be left to machines uh, to do the routine and the repeated thing. So that is the intention. As far as we can think of, although things are going much beyond that, the machines are going to become more intelligent than the human beings, and we can have a debate in the end on this topic. So with this, we move to a very important topic of understanding the importance of standards in our field and understanding the intent of standards. Because if you talk of standards, if you talk of so many technologies, so many OSI layers, and the pace at which things are growing, it's an ocean. But if we understand the importance and also the intent, if we ask those questions, why, I think we would grasp this subject better. If we design a system, some of the criteria that we think of, that the system should be reliable, it should be secure, scalable. When you talk of millions, billions, and trillions of devices, the system should not crash. All those tests, all those things which need to go in the design and in the architecture go there. Future proofing, it should not become obsolete. Uh, all the deployment scenarios, there can be different seasons, there can be different terrains, and in the end, affordable. So when we talk of these basic requirements when we design a system, the first point, that the system should be interoperable. This becomes our first requirement, and this becomes very important for us to keep in mind. And what is meant by interoperability, we will see in the next slide. So let us, to understand the importance of standards in integrating two systems. Let us imagine that there are two systems, system A and system B, which need to be integrated on an interface so that they start talking to each other. So if we have proprietary systems, system A is on a proprietary interface and system B has its own proprietary interface, then what happens? The cost of integration and the time taken for integration is huge. But on the other hand, if both the systems are on a standard interface, for example, both the systems are on RS-232, RS-485, IEEE 488 bus, then joining the two systems together becomes easier, and as a result the integration costs and the time are considerably lessened. But I am not saying that if you have a standard interface or a system which is having a standard interface, it doesn't automatically say that they qualify for plug and play type of thing. So this is what we are looking for, the two systems, when you join them together, you don't have to do anything. And the technology, the invisible technology does its work. And what is that? So this is the expectation. But how it can be proven? Because when you, connect a new gadget with your laptop, you need to, load certain drivers and then you need to configure certain things. So this is our the middle path. Uh, but If we are talking of plug and play type of systems, then what is that approach? There are two examples I would like to give here in support of this approach, which is followed by the 3GPP, the cellular technologies, and also in our field in metering, different metering suppliers, different communication people, different head-end systems. How you ensure that you buy any component from any company, and this will necessarily be a plug and play type of thing without any effort in integrating the systems. So let us take first the example of cellular. You go and buy any mobile from any shop, any make, and there are service providers like Vodafone, Airtel. You can take their SIM and insert the SIM. The SIM automatically works. The mobile automatically logs into the nearest tower and starts working and guides you to take the next steps for configuring and other things. And in that configuration also is done in the background nowadays automatically. So how this has been made possible, we will see some of the necessary steps. And same way in the metering industry, there's an organization IDIS which is helping the different manufacturers and the utilities that they can produce equipment which is ID certified. They can buy equipment which is ID certified, and as a result, they work with each other and they are fully interoperable. So the principle is going by the use cases. If you see, there will be thousands and thousands of standards and their clauses which are applicable to these standards. But here, what we are doing, we are focusing the use cases. For example, the use cases of sending an SMS, if we are talking of a mobile, using the same and using the telco service provider. So that use case of an SMS is fully elaborated. All the scenarios, all the variables that could be there for those, and then the solution is referring to some relevant standard and some clause of it, and then it is tested, and a third party tests all the required use cases and gives a certification that they have tested it in all scenarios and there are no gaps left. If there are gaps, they point out, and the party which is going for that certification fee proactively mends the gap so that there is no gap left. So this is an approach which has been successful in some of the cases, and where this approach was not taken, even after following the standards, there are a lot of issues in connecting the systems together. And in our context, as we saw in IoT, it is not about a device, it is not about a network, it is not about a single software. It is a combination of all. So there, when there are so many components delivered by different companies, there are going to be interfaces, and those those interfaces, they are standard and they are certified for the use cases of the system in all the scenarios. Things become easier. I think I have dwelled this point enough, and this is one of the key takeaways from this discussion. The next topic is the communication technologies. There are so many technologies emerging. Almost every year a new technology comes in. So we'll have a brief understanding of those technologies and the associated standards as well as the regulations. So when we talk of standards, it is also very important to talk about country-specific regulations, because both need to be followed for a good, happy experience later on. So basically, as we discussed earlier, there are two technologies: RF mesh, which works in home. Now Bluetooth is also coming up with 5.0, which is a Bluetooth mesh. As a result, the range increases and all the devices in the house, the gadgets can be connected together, and finally they through the home's router they can find a gateway as well for data communication. Cellular technologies and the power line carrier communication. There are different pros and cons. Different technologies are chosen for different requirements depending on the different regulations which are there in different countries. And now we see a lot of hybrid models coming in, where it is a mix of technologies. For example, within the buildings, it is power line carrier communication. Outside the building, it is the RF mesh for some to cover some area of the last mile. And then there is a gateway which is 4G or going forward 5G. So this type of implementations are becoming more common and will become a reality in the coming years. If you see the landscape of standards for different OSI layers, different technologies, so all of them are listed here, right from the file layer, MAC layer, network, transport layer, and on the top there is the application layer. For different applications, there are different standards. For example, for metering, there is DLMS COSEM for all the utility meters, where the syntax, the protocol, as well as the identification system is very well laid out, and it is based on the OOPS principle. So it is modern and future proof. Same way, there are other standards for head-end system to connect with the legacy enterprise system, enterprise ERP, and the other system which the utilities use. So I won't like to bore you much with these details. We move to the next slide. And we take an example of the application layer for utility metering, electricity metering, gas meter, or water metering, or the countries, the cold countries where the heat is also provided by the utilities. So the identification system of the objects and the profile, and then the protocol for data exchange. So all that is defined in an elaborate framework, which is called DLMS and COSEM. Now, just to draw an analogy between the DLMS protocol and the natural language that we speak, you see, I am speaking in English, and the same thing is being communicated over WebEx. So in DLMS protocol, this is defined by the physical layer or the data link layer. Next is what I am speaking is understood by all of you. So the grammar also becomes important. The sentences, what I'm speaking, where there is a full stop, where there's a question mark. So all that becomes part of grammar, and that is covered under the DLMS part. And then the next thing, which is also very important in order to understand and to have a meaningful two-way communication, is the dictionary or the vocabulary. So if I'm speaking English, you already know those words. So they are making sense to you. Same way, if the devices are talking to each other or talking to the head-end system, if they are speaking the same language, for example, the kilowatt hour, the cumulative energy register, which is the prime register for any energy meter, if it is having a very clear, unique identification, so that is provided by COSEM, and then all the variants, that cumulative kWh, and then the time of use registers, so with some extension. So that elaborate identification, object identification system is provided by COSEM. Grammar is covered by the Green Book, where it covers whether it is a get service or a set service, or an action. It could be an action. You are sending a command to a meter to connect or disconnect. Get means you are seeking some data related to billing or related to tamper log, or it could be an instantaneous electrical parameter profile which you want to get on demand. So it could be on demand. It can also be scheduled to push it. Setting means you are setting a configurable parameter. Action, I already told you, it could be an action related to an actuator working in the meter based on the command. Communication semantics and the scheduled event push. If any event occurs, if there is a power outage, it sends a message. It pushes a message to the head end system. So all that is covered by DLMS, and the vocabulary part is covered by the Blue Book or the OBIS system, which in its 6 bytes it deals with all types of utility metering objects and their profiles so that they are unique. If you are talking of one OBIS code, that means in the world it will be understood in the same way by all the machines. And then in the end, the testing is also elaborate, and a performance testing tool is available which takes care of all the positive and the negative test cases and validates the implementation thoroughly according to the protocol. Some of the examples of data exchange where client initiates a message for on-demand read, and meter being a server or the IoT device being a server, it acknowledges, and then the association request is sent. That is acknowledged, and then final request of getting a profile read is sent. It is got, and then a disconnection command is given, and as a result, the session which was started, it ends. Same way, there can be push events on different alarms being communicated to the head end system in real time. Configuration part. So there are different workflows which are associated, different timeouts. Those are also part of the standards and the protocols, and the stacks are available. You can also develop a stack and get it certified by the third-party labs. Coming to IoT technologies, so here on the x-axis we are having the ranges 0 to 10 meter. So you can see the NFC cards, the tap and go type of credit cards that are being advertised today advertised these days. So those all NFC technology, the RFID, all those are covered by this proximity 0 to 10 meter range. So there are different standards which specify NFC or RFID, and as we increase the range, there are so many other technologies, Bluetooth and Zigbee, which are supported by IEEE standards. And as we increase to kilometers, it becomes the neighborhood area where you can have IEEE 802.11 different variants. And then in cellular also 2G, 3G, 4G, going forward 5G, and in the low power RF area, working in the ISM band, Sigfox, LoRa, and so many other technologies that we hear about. So this is the full landscape to understand which standard applies for what type of range in RF technology. A table where we won't like to go into details, but it's worth to know that there are different governing bodies for different standards for different types of technologies. Wyson is an alliance. So what happens that a standard may not exist in the beginning because the technology is new. So what we have seen that some relevant and interested parties, they join hands and they start working on working standards, and they take it to a maturity level where the standard bodies feel that they need to adopt this. And this has happened many of the times. And this is, in fact, the way new standards take birth. And Wyson is one example where uh, it is meant for smart utility networks. It was started by a few companies, but again, in India, the government decided that the Bureau of Indian Standard should form a committee and start working on an Indian standard, which is based on Wyson. RF mesh, where uh, the neighborhood area communication works on the ISM band, the sub-gigahertz band. IEEE 802.15.4U has been ratified for the Indian ISM band, which covers 2 megahertz of bandwidth from 865 to 867 megahertz. Other countries, this is minuscule. So this is an area where lot many smart city implementations are coming up, and it will be worthwhile to see how the performance is upheld over the years as the space becomes more and more crowded. As an analogy, you can see that there is a narrow road on which a lot of traffic is expected. As a result, the performance of communication is bound to deteriorate and new ways will have to be found out. In US, FCC Part 15.247 clearly specifies how this free band can be used by all the users following certain rule of frequency hopping spread spectrum, or the channel hopping. So it clearly specifies that there should at least be 50 channels to hop on, and maximum dwell time one device can be on one channel is only 400 milliseconds, and it can only return to the same channel in 20 seconds. So you can see so much of time, 19.99, so much of time is available for other users to use it. And since it happens randomly, then that means that everybody uses an equal chance to use the band. And this, before you start using the free band, you need to have certifications from FCC. In our case, it is WPC, which certifies. But again, the rule for sharing the spectrum, how strictly it is implemented is a point of debate at this moment of time. 6LoWPAN, the IPv6 packets are compressed for resource constrained devices. So that is called 6LoWPAN in short. Bluetooth, we discussed that it is again a technology which is used by almost all the gadgets to connect with the mobile, and the mobile then connects with the right data center. India specific scenario on the ISM band, we have got two prominent bands here, and we are not talking about the 5.5 gigahertz, which is again become a very much used standard in the spectrum as far as the routers are concerned. So here you can see that the bandwidth is only restricted to 2 megahertz. So that is a problem today. If you compare with other countries, 26 megahertz is available in this spectrum in US, and in comparison, we are only having 2 megahertz, and Europe is even worse. So they don't have this RF mesh implementation. They rely more on power line communication or cellular communication. This is again a table with all the details, different countries and different spectrum ranges of ISM band, which is in sub gigahertz. Why I am saying sub gigahertz? Because uh, uh, going by the physics, going by the electromagnetic theory, lower is the frequency, better is the propagation, and better is the coverage for RF. So anything above 1 gigahertz is more like line of sight. So all that when it is discussed in context with RF mesh, it is necessarily pointing towards less than 1 gigahertz of carrier frequency. WPC certification, we already talked about that. Key points that uh, the bandwidth is limited. So what else can be done so that in the same bandwidth more information can be communicated? So new modulation schemes are now popular with OFDM. So this is something else people in the technology field we need to be aware of, how to increase the spectral efficiency. Cellular, uh, mainly long-term evolution or 4G. So this is a spectrum, or this is a, service LTE or 4G, which is going to be supported by the service provider for long years. And 5G also encompasses 4G. 4G is not going to go away, whereas there is a big doubt how much longer can we have 3G or 2G being supported by the telecom players, because they are not earning any revenue out of it. No application in your smart mobile today works efficiently on 3G any longer. So 4G is a necessity, and good thing is it is also termed as long-term evolution, because people were always asking questions that how many times do I have to change my mobile? You came out with 3G, I was very happy, bought a new phone, and then you came out with 4G, now 5G. So am I a fool? uh, so all those questions they answered by calling 4G a long-term evolution. And in this also, it starts right from very low-end communication, a few tens of bytes being exchanged every day. That is CAT NB1 release 13 and release 14 by 3GPP. CAT M1, which is not supported in India for medium type of requirements like variables and some low-end meters. Cat 1 is something which is supported by everyone: Airtel, Vodafone, Jio, and BSNL. So this is again a technology of interest, or a spectrum of interest, that some few thousands of byte. If the throughput requirement per device is of that type, then Cat 1 could be a very good cost-effective option. And Cat 4 is the full-blown LTE, 100 Mbps and some gigabyte per day type of throughput. Uh, so this we already discussed why 4G is a potentially long-term solution, because it works in a license band where we don't have to bother about someone else occupying the same bandwidth. Reliability and cost effectiveness, with the more devices coming up, with new standards coming up, this is becoming more and more robust. NB-IoT for the very low end resource constrained battery operated sensors, how does it compare with an unlicensed band LoRa performance? So this is there in this different parameters are compared, and you can see NB-IoT scores over quality of service, latency, performance, range, and in some cases like coverage deployment, it is uh, inferior to LoRa. 5G, a lot more to look forward to. Totally a different technology, going to tens of gigahertz, 40 gigahertz, 50 gigahertz, where massive MIMO and other technologies, the antenna arrays, where the line of sight communication like you have in satellite, it is going to follow that route. But again, with the higher frequency, a lot of bandwidth is obtained, so that augmented reality and such applications in vehicle or elsewhere, they can be realized on 5G in the future years. power line communication from multi-carrier communication as a speed has increased and reliability has also increased. There are different standards different countries follow, and FCC up to 490 kilohertz. It is followed in America, Japan. It is up to 450. In Europe, it is a few hundred, up to 95 kilohertz or 140 kilohertz. So generally, the study says that modern devices are emitting noise uh, in the lower region, and as a result, the FCC standard, which goes at 480 kilohertz of carrier frequency, it becomes safer from the noise. So different speed comparisons of modulation techniques. Uh, in the end, before we end the session and open it for an interesting debate, some challenges are also seen and some mitigation actions are also suggested here. Security becomes very important, and uh, we can say that as the systems are shipped out, there can be some bugs. We can't take care of all the bugs. So firmware over the upgrade becomes a good tool to address that, and it has become a regular feature in almost all gadgets. The mobile gets a system update, the computer gets a system update, and same is true for all the devices. But in LoRa and such small communication devices, how the FOTA will be local resistance. Anything new which you do will always be met with a resistance. There are always some people who are benefiting when the system is not transparent. So those people are the ones who, the media and other things. So those negative things are sponsored in most of the cases. But if the consumers are provided the data with transparency, I think that cause can be held by this measure. Functional failure mode and effect analysis to foresee the problems and mitigate those is a technique which should be used when before such systems are designed, before design. So you know where the failure possibilities are there, and in design you strengthen that either by redundancy or by having a more reliable component. The component could be hardware, it could be software, it could be a mix of the two for that function. Security again becomes a very important topic. We will not be doing justice if we start talking about security because it is deeper. But each interface has a vulnerability, and this needs to be addressed at each level and third party certified. So with this we end. I think the what I would like to emphasize is don't be bogged down by so many standards and their clauses, but a use case approach and keeping in mind the intent of the standard or a clause, it helps us as engineers. Thank you, and Professor Parikshit, I would like to request you to suggest how we can have a meaningful discussion, a two-way communication where we learn from each other.
Uh, uh, that some hands are raised, sir. There is one
Yeah.
Umesh Prabhu, sir. Can you unmute yourself and ask the question?
Yeah, good morning, Professor. I am Dr. Mohan from Bangalore. I have a small
Hi,
doubt.
good morning.
So, just you said that WISUN making some standards. and by that people will accept and agree and plan for the example 4G or 5G frequency band or the frequency range they allow. But the environmental consequences, how they will understand immediately. The public acceptance, how they will come to understand. Only publicly when it face it after long run, let's say 2 years after, the effect may be huge. Example, 3G itself spoiled a lot of birds. And there are many other unknown factors are all coming. Some people are telling the heart attacks increased because of 5G in China. They already implemented something like that. News are coming. Please kindly put some note on this, Professor.
Yeah, so uh, limited understanding that I am having. So when these committees they discuss the standards to be followed in a particular country or elsewhere, uh, first of all, it's a panel of experts. So they take into account all the aspects, the effect, the negative effect on the people or on the nature of that frequency. And as a result, they restrict these telco players not to emit more than a certain frequency, and that is supported by the medical research papers and other things. And then there are other agencies who take care that if there is a complaint, that if someone is finding that the tower is too close to his house, he can make a complaint, and uh, that can be taken care of. And precisely for that reason, there are standards. So you are not following what one is saying. It could be an individual thought, but when it is published in a standard, it follows a process. It is, consistent reviews, consistent references to many other published work. So it's a very scientific way. But what happens that when it comes to business, there are a lot of things uh, uh, which are bad
Bypass.
practices.
They bypass.
Bypass, in order to reduce the number of towers, reduce their cost, these telco companies might be increasing the power. Who knows? So all that checks and balances in the system, and making the system such that the human intervention is not there. If there is a violation, it is immediately flagged and it is recorded, rather than an inspector who is bribed and he
Yeah, yeah.
looks the other way.
Correct.
So I think a very relevant question, and in my opinion, the standards address this aspect in a very scientific way. But if it is a social menace, it has to be, addressed differently,
Okay, thank
because
you,
the
Professor.
same cellular systems are operating in other countries. So, do we see the same effect on birds? Or if we don't see, then is it because the power that they are emitting is according to the standards, and here we might be seeing violations? We won't be able to answer this question, but that is my point in answer to what you raised.
Professor. Even W van is increasing. It is now 5 kilometer, 10 kilometer range is further going. 5G after what next? Question mark people are thinking. Anyway, thank you, Professor. Nice answer, Professor.
Thank you. Thanks a lot.
Thank you, sir. There is one question from Dilip Moyal, sir, that from where to learn all these protocols because he is from electrical engineering background.
Yeah. So again, uh, focus on the application. What you want to achieve, what is your system doing, what is the function, and according to that, if we break down that system into layers and Google, we would be able to know what are the available standards which address that particular layer. And when we talk of layers, means it's a module, and it interfaces with the other layer within the system or outside the system through an interface which is described by the standard. So standard describes the physical interface, it describes the protocols and all the OSI layers. So depending on the case, there will be different systems, and if you break down the system into layers and Google, you might be able to know what are the relevant standards for your particular requirement.
There is Sameer Jain, sir. He wants to know about precision agriculture and how DLMS protocol works. I think precision agriculture can be answered in later sessions when Professor Navneet Goyal and Dr. Meeta Shinoy will be there. So this question can be the DLMS protocol. Sir, you can take it up.
Yeah. So DLMS stands for Language Message Service. So this is a standard which is there to define the data exchange between the utility metering devices and the clients. A client can be a handheld unit on the other hand, or it could be a full-blown head-end system which is interacting with millions of endpoints on the other hand. So DLMS, as I described, that it has got two parts, and it is adapted by IS also. So IS 15959 is the number of the standard which is used in India for data exchange in data exchange between the metering devices and the heading system or the handheld client. Uh, Rest, I think a lot of literature is available. As I described, there are blue books, green books, yellow books for testing. So these are big books which describe. But in a nutshell, it is important that if certain things are written in the standard, why it is written. So that I covered briefly in this session. That if I am talking to you and you are talking to me, we are understanding each other. So it comprises of three things. One is the medium. So we are talking through the physical layer and the medium of WebEx. This is one part. The second part is the language, where I'm speaking in sentences with full stop or comma as a separator. Uh, so that grammar part is coming up, and the meaning of the words is also known to both of us. So the vocabulary part. So the DLMS COSM standard consists of all these and all the parameters. It could be a temperature, for example, which is measured by a sensor. It could be a cumulative kWh register, which keeps on increasing as you consume more energy over time. It could be the RTC, the real-time clock in a device. So all these parameters are identified with an OBIS code, which is unique in the world, which is very well defined in the standard. For example, if I am talking to you, I know your name, your surname, and your institution. So that way, it is a unique identity. If I send a letter to you, it will reach you and it will not be confused with someone else. The same way, all those parameters are given a unique code, and that code is displayed on the display also, and the value and the unit of that object is also displayed. And when it is communicated, it is also communicated through a set standard. That first the header is given, and then it also defines the OBIS code and what attribute of that OBIS code it is. And then when it could be a profile also, which is a combination of different objects. It could be like, for example, you capture all the registers in a meter. It could be a cumulative kWh, the time of use registers at just at the day change or at midnight. So all those parameters which are captured, they are put under, because they are all having, those parameters are having OB scores, but since they are captured at midnight, they become part of a profile which is again identified by another unique OBIS port. So when you are capturing the midnight captured objects, you ask the server to give you the value of that particular profile. So it gives you all those parameters which were captured last midnight. And if you want to have a sequence of that, there is a command that selective access. So many last midnight captured values and so many profiles can be read. So it is quite elaborate and it will be difficult to explain more than that in this session.
Sir, there is one question on why 5G will require millions of small cells.
So 5G, as I understood, this works at very high gigahertz frequencies. The uplink and the downlink in a satellite communication is something like 10 to 20 gigahertz, and 5G works at higher frequencies than that. So what does it mean? That it is a very straight pencil beam a wave, and it is not a wave which is at lower frequencies, which can travel, which can bend. So what does it mean? That there will be many towers required compared to the number of towers that we have, but the power for each connectivity will be adaptive, and it will keep on switching, and the antenna and other technology which comes under the subject massive MIMO, it will when we read that, we will know more about how things will work in 5G. But one thing is very clear: you will be seeing many poles supporting 5G on the streets, and things will become very fast. And the first question, what will be the impact on nature? This is something we need to watch for. I hope I answered your question.
Mr. Parveen Rajput, sir. Uh, Thanks. He has given thanks to you, sir. Uh,
Right.
then there is Dr. C.H. Vithlani, sir, is there. He wants to know that IoT is using too many standards starting from physical layer to application layer. Is there any possibility to limit the standard and use only one protocol in each layer?
I think the answer is the same, that focus on what we intend to do and pick up the relevant standards, pick up the clauses and implement things according to those clauses. So it need not have to, follow one standard, but the end-to-end functionalities or the use cases need to be understood, documented comprehensively, and accordingly one can think of following the standards and certifying that end-to-end functionality rather than certifying for the function. The standard is only a supporting having a supporting role. It is not mandatory, but we are implementing something. It cannot be proprietary. It has to be published somewhere in the standard, and we are picking that particular thing which is relevant to that scenario or the use case. So that is exactly what I wanted to communicate, that if we look at standards, there are so many standards, evolving standards, changing standards. We tend to lose focus on what we actually want to achieve. And for evaluation of standards, new standards, the government has so many committees, and if we are part of that field, one can apply to become a member and attend those meetings.
Is Ramesh B. sir wants to know is what is the difference between XB and ZigBee protocol?
As far as I understand, whether it is XB or ZigBee, both are becoming irrelevant in today's concept. And if we talk about the last mile communication between the gadgets, between the mobile and the gadgets, uh, uh, it is being taken over by Bluetooth in a very big way, and lot many enhancements are also taking place. So exactly the difference between the XP and the ZigBee, I will not be able to answer here. But as far as the relevance is concerned, it's better to follow something which is followed world over. It is supported by different parties, different vendors, and a lot of research is also going on to make it faster, make it cover more space.
There is one from Anand Achyut Rao sir. He wants to know which are the protocol useful in real-time IoT application.
Real-time IoT application, again, depending on the application, we'll have to see a physical layer. If it is RF technology, we can have IEEE 802.15 or 802.11 dot so for the PHY and the MAC. And then for the network layer, it could be IP V6, or it could be RPL for RF mesh, or any other for the network. And for the transport layer, it could be UDP or TCP. And then in the upper layer, depending on the application, it will be following different application layer protocol. For example, I gave you an example of DLMS QoSIM for utility meter. And for the head-end system, it is CIM, some number was there. So it depends case to case which protocol will be followed for which application and for which layer.
One second. One second, sir. Uh, One is Mr. Parveen Rajput again. He would like to know that how will 5G change the wireline architecture that currently supports 4G mobile backhaul?
So again, very important to know that fiber is reaching each building. So that's a reality. In my building, we have got two fibers coming in, one from Airtel and one from Jio. So with 5G coming in, will those become redundant? If that is the question, my personal opinion, that will not happen. Second thing in support of that is the first question, that more RF we have in the environment, more paranoid we feel. So better to have the backbone working on the wired communication, the cables going through oceans. I think this is not going to change even with 5G coming in. What is going to change with 5G is that the connectivity of the mobile and the ability of the mobile sets and other gadgets to run the application, the gaming and other things, virtual reality, augmented reality. So that 5G is going to enable some applications in medical where you need real-time processing and lot many channels being accessed by a surgeon where the patient is somewhere else. So all those, good things will be enabled by 5G, but in my opinion, it is not going to change that the optical fiber is getting us a backhaul to every building, or other forms of wired communication. And 4G is going to live along with 5G, because after all, there is a cost also which is associated with each new technology. So good. I think we all are confused. So that's a very honest statement. that with new technologies coming in, what to leave and what to adopt, and is there a commercial motive behind all that? I think this is the point which is confusing everyone.
So I think you have answered almost all questions, sir, and that I could see from the chat box that all the audience they are very appreciative of your lecture and the information you have given on the industry standards for IoT. So I think it has been highly valuable for them.
Thank you, sir. I also enjoyed the lecture and the questions, and I would request that when you have your curriculum, please touch upon the importance of standards also, because otherwise the students learn about them after they are inducted in the industry. So a very interesting debate can be on whether standards uh, come in the way of innovation. So can someone answer this question from me, from the audience?
What is the question, sir?
Yeah, the question is that there's an interesting topic that we talk of standards, the importance of adhering to standards and the standards being there to support the new technologies. But the question is, isn't, don't you feel that standards come in the way of innovation? Because standards bind you that you have to do it in this way only. And then you're trying to do something different. So do they come in the way, or
Sir, it has two aspects. One is from the aspect of the academia and the researchers, and second aspect is the from the commercial side. So let's say the country like India, we are at a developing stage. So we are not into the innovation of the standards. So we follow the standards right away. What the countries have made it. For example, US, UK, Germany, Europe, and so on and so forth. So that is what the commercial aspect, because they are investing money in the research side and they are defining it, all those standards, and we are going to follow the standards. We are not making the standards. So this is one aspect. Second aspect is, if we make it, then how do we validate that standards? Who are going to means what are the authorities that who are going to give the inline of approvals? Because in India, if we do something, some research, it has so many pros and cons there, and same as with the standard as well. For example, I have remembered Delhi Technology University, DTU. So they had made hydrogen car way back in 1990s, and it was line up outside of the university campus. And right now, everybody looking into that car, and nobody was going to invest the money into that prototype. So this was a problem, I think, what I feel so, because we have seen industry in a very deep sense, but the problem is same. Yeah, we follow the things, we are not making the things. That is what my answer, sir.
thank you so much. Good answer. I think hydrogen car, when it was invented, probably it was not, people did not understand its value as they are doing now. So something which comes ahead of time is probably also not understood by general people. And you are right that followers more than the innovative researchers. So I think that should be encouraged. And I want to give a message that standards don't come in the way of innovation. When innovation proves something that it is to be used commercially, there will be enough number of parties and people and companies who will be making extra efforts to support a standard on that proven thing.
Uh, Thank you so much, sir. I think we have come to end of the session. We would again would like to have in the near future, sir, for giving coming to us and sharing your experts with the audience or the students in similar workshops, faculty development programs.
Thank you, sir. Thank you for giving me this opportunity, and I'm really happy to be part. Thank you.
Thank you, sir. Now, for the audience, we'll meet at 11:30 a.m. And there is a slight change in the schedule that today we will have the session on the self-management key to happiness. That the afternoon, whatever we had on the Wednesday afternoon, so that we have to shift it to here. And the Dr. Anukram Majumdar's session will be there on the Wednesday afternoon. So there is a slight change. I'll update on the email as well as WhatsApp also. So thank you, everyone. Again, thank you,
Thank you,
sir.
sir. Thank you. I'll leave the meeting now. Thank you so much for your time.
Yes, sir. Thank you, sir.
Thank you, sir. Thank you.